In this video, we will solve absolute value equations. The absolute value of a number refers to its distance from zero on a number line. We denote the absolute value with vertical bars. So we might have the absolute value of -5, which is written with vertical bars around the -5. And when we see that notation, that means that for us to respond with how far is -5 from 0 on a number line. So if I draw 0 and go to -5, how many units did I have to go? Well, I had to go 1, 2, 3, 4, 5 units. So the absolute value of -5 is 5. What about the absolute value of +5? How far is that number from 0 on a number line? Well, +5 is just in the opposite direction, but it is 5 units from 0. So the absolute value of 5 is 5. So notice that a number and its opposite have the same absolute value, and that is because they are the same distance from 0, just in different directions. Now, the other thing I want you to observe is that the absolute value is not negative. Because distance cannot be a negative number. So the absolute value can either be 0 or a positive number, but it can never be a negative number. So let's look at some basic absolute value equations and get the gist of what those mean, and then we'll go to some more complicated equations. The absolute value of x equals 4 tells us to determine what are the values of x that have a distance from 0 of 4. Well, if we think about a number line, the numbers that have a distance from 0 of 4 are going to be +4 or -4. So this means that x is equal to 4 or x is equal to -4. So the solution set for that equation is ±4, or we can list those separately as -4, 4. The absolute value of a equals 37 means for us to find what are the values whose distance from 0 is 37. Well, again, if you visualize a number line, I can go to either +37 or -37 and maintain that same distance. So we would have that a has to be 37 or -37. So the solution set is ±37. The absolute value of x is equal to 0 means to find what numbers have a distance from 0 of 0. Well, 0 is the only number that has a distance of 0 from itself, so we would say that x is equal to 0. And then the absolute value of b is equal to -5 is asking us to find what numbers have a distance from 0 that is -5. And there is no such number. Distance is always positive or 0, but never negative. And so there's no solution to this equation because of the negative sign that's equal to the absolute value. So we can actually summarize those types of cases into 3 general statements, and we'll call this property 1 for solving absolute value equations. And property 1, part 1 says that if the absolute value of x is equal to k, where k is some positive number, then there are 2 possible solutions. The number inside the absolute value can either be +k or -k. If the absolute value of x is equal to 0, well, the only way that can happen is if the inside expression is equal to 0. And then the last part of this property is if the absolute value of x is equal to k, for k negative, then there is no solution because there's no number that I can substitute in place of x whose absolute value will be a negative number. So to apply this property, there are a couple of steps that we have to go through. And the first step is that we have to isolate the absolute value expression on one side of the equation, because we need to figure out what is the distance from 0 of that inside expression. So we have to isolate the absolute value first, and then we're going to apply property 1. So if it's equal to a positive number, there are two solutions. If the absolute value is equal to 0, then there's just one solution. And then if the absolute value is equal to a negative number, then there are no solutions. And once we determine which of those cases we're in, we'll just solve those resulting equations. Now here's a tip to help you remember this, hopefully. Think about the absolute value bars as the field goal on a football field. And before you can kick the football through those goalposts, you've got to get down the field, right? You've got to clear the field of all the obstacles before you get that opportunity. And that's what we want to do in an absolute value equation. We need to clear the field or clear the absolute value expression from anything outside of it and get it isolated to one side. And then we can either make points when we kick that field goal or not make points. So that hopefully will help you remember that there's two possible solutions, that the inside expression has to equal the positive number or the inside expression has to equal the negative number. Now that's only when the number on the right side is a positive number will there then be two possible answers. So let's look at some examples. Part A is absolute value of x is equal to 6. So we have the absolute value isolated equal to a positive number. So that tells us we want to set the inside expression equal to the numbers whose absolute value is 6. And that is the numbers whose distance from 0 is 6. And that can either be 6 or negative 6. So we're going to set x equal to 6 or x equal to negative 6. And those are already solved for x. So our solution set would be plus or minus 6. Part B is the absolute value of x plus 4 is equal to 10. So notice that the absolute value, right, the vertical bars, our field goal, is isolated to one side. So we're going to apply the property that says if the absolute value is equal to a positive number, we're going to have two solutions. So we have to set this inside expression equal to the numbers whose absolute value is 10. So that is, what numbers have a distance from 0 of 10? Well, that's either positive 10 or negative 10. So this inner expression has to either be positive 10 or x plus 4 has to be negative 10. So then we solve these. These are two linear equations. We can subtract 4 from each side to get x equals 6, or subtract 4 from negative 10 to get negative 14. So our solution set is negative 14, 6. Remember to write them in order from smallest to largest. And then I can check my solutions. If I plug in negative 14 in place of x into the original equation, I get, is the absolute value of negative 14 plus 4, is that equal to 10? Well, the inner expression, negative 14 plus 4, is negative 10. And the absolute value of negative 10 is 10, so that checks. And in a similar fashion, if I plug in 6, 6 plus 4 is 10, and the absolute value of 10 is 10. Part C is the absolute value of 2x plus 3, then minus 4 equals 1. So remember our tip, we've got to clear the field, clear everything except for the goalpost. So I need to add 4 to each side, to get the absolute value on the side by itself. That gives us the absolute value of 2x plus 3 is equal to 5. Now I have to ask myself, what are the numbers whose distance from 0 is 5? And that is positive 5 or negative 5. And so I want to set this inside expression equal to 5 or 2x plus 3 is equal to negative 5. And now I have two linear equations that I can solve. I first subtract 3 from each side, so 2x is equal to 2, and then divide by 2 to get x is equal to 1. Or if I subtract 3 from the second equation, be careful here, subtracting 3 from negative 5 is negative 8, and dividing by 2 is negative 4. So my solution set would be the set containing negative 4 and 1. And I can check, right, if you want to plug in place of x, we're going to put negative 4. So that would be 2 times negative 4 plus 3 in absolute value minus 4, is that 1? So we would get, what, 2 times negative 4 is negative 8, plus 3 is negative 5. So we have the absolute value of negative 5 minus 4. Is that equal to 1? And it is, right? Absolute value of negative 5 is 5, minus 4 is 1. Part D is the absolute value of x plus 1 plus 6 equals 5. So we need to clear the field again, get the absolute value on the side by itself. So we get absolute value of x plus 1 is equal to what number? Right, I've got to subtract 6, and 5 minus 6 is negative 1. So I have the absolute value of x plus 1 is equal to negative 1. So I'm thinking, well, what numbers have a distance from 0 of negative 1? But there's no number that has a negative distance, and so this is no solution or the empty set. Now, there's one other property that you're going to see, and that is when you might have the absolute value equal to the absolute value. So this property states that if the absolute value of x is equal to the absolute value of y, then x has to equal y, or x has to equal negative y. So what this is saying is that the only way that two absolute value expressions are equal is if their inner expressions are the same, or if their inner expressions are opposite. So you have to set those inside expressions equal to each other or opposite of each other. Like for instance, right, absolute value of 5 is equal to the absolute value of 5. But the absolute value of 5 is also equal to the absolute value of negative 5, right, because they're both 5. So the numbers are the same or opposite for this property to be true. So here's an example. I have the absolute value of 2x plus 7 is equal to the absolute value of x plus 5. So for this statement to be true, it must be that 2x plus 7 is equal to x plus 5, or 2x plus 7 is equal to the opposite of x plus 5. So one of those quantities stays the same. Notice 2x plus 7 and 2x plus 7, but then I set it equal to the expression itself or to the opposite. Solving these, I can subtract x from the first equation on each side to get x plus 7 is equal to 5, and then subtract 7, so x is negative 2. And then for the second equation, 2x plus 7 equals the opposite of x plus 5. I need to distribute to get 2x plus 7 equals negative x minus 5. Remember, there's an understood negative 1. And now I can add x to each side. So I get 3x plus 7 is equal to negative 5. And then I can subtract 7 from each side to get 3x equals negative 12. And then divide by 3. So x is negative 4. So my solution set is negative 4, comma, negative 2. And again, I can plug the values of x in to see that I get a true statement. And then the last example is just an application problem. It is a hazardous chemical spill of titanium tetrachloride occurred at mile marker 331 on an interstate. Emergency management personnel stated that motorists should be a minimum of 12 miles from the site of the spill. At what mile markers should police block traffic to keep motorists safe at the minimum distance from the chemical spill? And so what we're saying here is that we're at mile marker 331 and that we've got to be 12 miles from the site. So we've got to be a distance of 12 in each direction. And so what that is saying is we don't know what that mile marker is. We're going to call it X. But we know that the distance between X and the mile marker 331 has to be 12. So we can represent the distance by absolute value. So we would say the absolute value of X minus 331 is equal to 12. And then we can say that X minus 331 has to equal positive 12, or X minus 331 is equal to negative 12. So to solve each equation, we're going to add 331 to each side. So 12 plus 331 is 343. And then if we add 331 to negative 12, we get X is equal to 319. So police should block traffic at mile marker 319 and mile marker 343.